Hello everybody, this is your community pharmacist, and in this video I'm just going to be going over my method of calculating the aliquot. I had a request to explain how I do it a little bit more in depth, and so that's what we're going to do today. So for our first, really, and our only problem, we'll just have different scenarios. This question reads, how would you weigh 40 milligrams of drug B on a prescription balance with a minimum weighable quantity of 120 milligrams? So now our quantity that we want to weigh is less than our minimum weighable quantity, so we have to do an aliquot. For this, what I do, and I'll just go over my method once again. So 40 milligrams is what we need. I subtract it from the minimum weighable quantity just so I can get a ratio of how much drug I need in the aliquot and how much diluent I need in the aliquot. And for this, the diluent will be lactose. So 40 milligrams minus 120 milligrams. Now I do it this way, you're going to say that this will lead to a negative number, but I'm just taking the absolute value of this so I can get a real number for my diluent. And that would be 80 milligrams of diluent. So now I take 40 and I see how many times it goes into the minimum weighable quantity. And I take that factor and I multiply it by both sides just so I have an equal ratio. So 40 into 120 goes in 3 times, and that is 120. So now I have to do the same thing to the other side, multiply by 3. And that gives me 240 milligrams. So this is my drug, and this is my diluent. So now, this number here will always be, for my method, the aliquot. And this is because no matter what we're multiplying these two sides by, the ratio is always going to add up to 120. So 40 plus 80 is 120, 40 plus 80 is 120, so on and so forth for however many factors we have. So now let's say that we have something that does not, because somebody might be confused by this, right? 120 milligrams of drug is the same weight as the quantity, or the minimum weighable quantity, which is our aliquot. But let's say we had 50 milligrams that we needed to weigh. Subtract that by the minimum weighable quantity, and you get 70 milligrams for your diluent. Okay, 50 into 120 doesn't go in perfectly. It goes in by 2.4. Now, I don't care about what this factor is. It doesn't have to be a whole number. All I'm looking for is that these final numbers here are whole numbers. It just makes my life easier when I'm weighing them out on the balance. Okay, so now I will still only take 120, because no matter what this is, and no matter what this is, your ratio is the same. I multiplied 50 milligrams by 2.4 and 70 milligrams by 2.4. So I'm always going to take 100, whatever the minimum weighable quantity is, as our aliquot. And that's okay, because that's your minimum weighable quantity for a reason. You can weigh that. So now let's say we had something different, and I'm going to try and squeeze this in down here. Let's say you wanted to, because we're not always going to need to measure, weigh out something round like this, 40 milligrams, 50 milligrams. What if we need 42 milligrams of the drug? That is 78 milligrams for the diluent. So 42 into 120 is not a perfect decimal, and it's certainly not going to give us a total number over here. Try and squeeze that in. So the factor is 2.85 whatever. It's a very long decimal. Multiply by both sides. Okay, 227.857, da-da-da-da-da. So I don't like leaving off with those numbers. I want a whole number. So I'll make the factor the next whole number. So in this case, it'll be 3. forgetting this, and forgetting this, multiply both sides by 3, and you'll get your new values of, okay, so I'll put drug over here, diluent. So 42 times 3 is 126, and 78 times 3 is 234. We've got whole numbers. What will our aliquot be? 120 milligrams. That's never changed. Hope that helps. I hope that explains it. If there are any more questions, please leave me a comment below. And just like these videos, it helps it get to other people. Thank you.